Hi, this is a walkthrough of week 4, day 2 on evaluation of RAG using RAGAS or RAG assessment tool. So we're going to go through this notebook to install the required libraries, set the environment variables, and create a simple RAG pipeline using a LangChain version 2.0. And we're going to generate some synthetic data so we can evaluate whether it's working okay using the RAGAS framework. And then we're going to try to make some adjustment by swapping out the language models, embeddings, and see how they perform. And we'll see if OpenAI is newer model is good, and if so, how much better. So we're going to go ahead and install the required libraries, including LangChain to OpenAI interface, and a bunch of other things. And we're going to also install the RAGAS. And we're going to put our text data into Quadrant database, and so that we can easily retrieve the relevant context that matches the queries and also to the grounded answers as well. So we're going to pass in some API keys. We're going to go ahead and create a RAG pipeline using a version 2.0. And first thing we're going to do is we're going to load the Paul Markup blog archives. And we're going to test out to make sure that it kind of works. We're going to process the text by splitting them into chunks with a chunk size of 200 and overlapping 50. And there's about 1,864 documents there. Thing we're going to do is we're going to load the base model, which is from OpenAI's the ADA002. And we're going to load the embeddings into the quadrant in memory, so it'll improve the speed quite a bit. And the first question is, how does the quadrant make it perform better? And this is the six things that came up from the Quadrant's webpage, and I highlighted the three things that are directly related to the performance part. First thing is efficient storage and indexing of high dimensional data. The second thing is handling large scale data set, and this is the you because it's stored in the in memory as opposed to external memory like the hard drives or SSDs. uh, you get a better performance because you don't have to transfer data back and forth between the main memory or the RAM and to the external storage place, so that therefore you have a reduced latency. So once we have the quadrant vector database created, we can retrieve the relevant documents from it, and we can try to run some test cases like using an invoke function to ask a question, and then we can process the retrieved documents by printing them out. And nice thing about the RAG chain is we can put together a series of tasks or completions of various functions. And so we're going to put together a prompt template by pulling from the LangChain hub. And we're going to use someone else's nicely designed QA chat template. And so we fill in the basic template, and we're going to pass in the context and the question as part of the variable. So once we have the prompt template set up, then we're going to send the questions in parallel. So one to pass it off to the language model at the end of the chain, and the other one is to use the query to query the database, vector database, to retrieve the relevant context that can provide answers. And finally, the retrieved context can and the response can be put together with the original query to generate the final response that will hopefully be the correct answer. So we test it out, and we can see that it works pretty good. If it doesn't know, then you're going to say I don't know. If it has the good answer, then it's going to try to generate the answer. So to test whether this works okay, does it actually generate the right answers based on the actual relevant context or not? We're going to use a um, RAG evaluation framework called the RAGAS, and it has a five different dimensions that we can use to test whether query is query relevance to the context, context relevance to the grounded answer, and generated answer is relevant to and faithful and accurate to the um, context and grounded answers. So there are 5 dimensions that we're going to use. So we start with by generating a um, sample or synthetic test data, and this will save us some time and human labor and cost, and gives us a good place, a starting place to do this. So we're gonna go ahead and answer the load the PDF loader, so we can generate do some evaluation data. Second question is, why is it important to split our documents using different parameters? Because having a smaller chunk makes it easy for the hardware, whether it's on local or whether it's online. Um, uh, and then we see this quite a bit because depending on how many chunks are being fed through the whatever model or whatever hardware that you push, uh, it's going to be limited in terms of how much and how fast and how costly it can return. So we'll see there's a bunch of limit issue with the OpenAI models. And even if you run it on your own computer, then it may be limited by the hardware that you have. So in either case, I think it's always important to see if you can reduce the chunk size as much as you can without giving up too much quality. And of course, a smaller context window may actually get even better accuracy, because if you test the AI model to look for the correct answer in a really large, broad context, you may actually get the wrong answer. It may start to generate hallucination or the wrong information as the final answer. So that's the shorthand version of question number 2. So we're going to go ahead and run this through. Uh, we're going to go ahead and feed we're going to use 3.5 as the generator LLM. And then we're going to use GPT-4o, theoretically better, as a critic LLM, so we can kind of compare and test and contrast. And I'll go over what the distribution of simple response versus multi-context response and a reasoning response, so we can get a different complexity in terms of the response that it generates, which actually will be better to test whether it's really working well or not. And here, after multiple tries, the too many documents just didn't work that well. So we randomly sample 50 documents, generating 20 different responses um, to be able to complete this without running into limit issues. So here's sample documents that we generated. And then I pointed this out because I think it's the rate limit is pretty bad. So they had to do some multiple hacking around to make this work. Just to simply go over what this distribution means, this is according to the definition of the RAGAS. Document reasoning rewrites the question in a way that enhances the need for reasoning to answer. Basically, it's a little more complicated than just a yes or no or whether which answers. So there's a little more complexity in the kinds of questions and the response that it generates. Conditioning means it's a conditional statement or conditional question. Again, it's trying to make it not that simple, and having a more complex would test the model a little bit. And this one is a multi-context, which is rephrasing the question in a manner that can handle different ways that people may ask, or looking for different kinds of context. So having these 3 different types of responses generated would be helpful in testing whether the language model really works in terms of RAG. So we're going to generate a response with the RAG pipeline, and then we're going to put together with the question, context, ground truth by creating a answer columns later. And then we're also going to use a numerical version to test if that works. So we move on, and we're going to generate the answers, generate the answer from the RAGA synthetic data. Um, so we're going to merge in all these columns. So we'll have a one data set put together. Um, and here's what it looks like. Moving on. And so this is the 5 dimension, which allows us to give a numerical version of whether um, the whether it's working or not. And so we put together uh, the question, answer, context, and grounded truth against these five dimensions, as well as the human eye, to test if the evaluation of the model is good or bad. And because of the rate limit, I had to put some async IO modules. I also tried a bunch of things to essentially slow down so that it won't hit the per minute rate, as well as the total tokens per minute. So there are two different rate limit that made this exercise quite difficult. So essentially, after multiple tries, by changing the rate limit per minute, putting in some extra buffer to wait so they won't hit the rate limit, I was able to generate the response after multiple tries. And so we can kind of compare the responses, and you can see that everything has been generated correctly. And moving on to the task two is to swapping out the models, the critic models, the embedding models, and so that we can kind of compare, is one version of the OpenAI better than the other. So I'm going to skip through the rest of the codes because essentially I had to send multiple calls to get smaller pieces of data set and put it back together again. So at the end of the day, if I skip all the way through, swapping out different things, comparing as baselines, um, and because it was trying multiple times, it generated a lot of these warnings and retries and max tries and all that. So let's go to the final finish line. So the final answer is the the text embedding 3 plus GPT-4o with the multi-query seems to be better, but maybe it's because I'm only using 50 documents and to generate the 20. It's better, but it wasn't that much better. So that's the end of the demo.